Hey, it's Mike Draper with AWC TV, and we've got a couple really special guests you guys are really going to pay attention to. We have Brent and Landon with C3D Solutions, and these guys are really cool. They got some great technology. Guys, thanks for being on board with me. I really appreciate it, and really excited to talk to you guys.
Thank you for having us.
Yeah.
We really appreciate it.
No problem. So give me your guys' background. Where'd you guys come from before all this started?
Well, I've been window cleaning since I was about 15. It was my summer job with my best friend's dad. He used to window clean in New York, and he moved to Oklahoma, and that was, kind of my side gig in the summer. And then when I got out of the Army, whenever we were short for money, I would always go back and forth to window cleaning because you can get some fast cash in their houses and everything. And, finally, we had another business, and I was like, I want something that I know very well. And just in my area, there's not a real market for a real professional looking corporate style, I guess, window cleaner. So I got back into window cleaning and just kind of went from there. And then Landon,
So about 2 years ago,
Yeah, let Landon talk already, man.
So about 2 years ago, I started working for Brent, and I had no idea what window cleaning was or anything. So my background is I'm really into technology, engineering, and innovation. So after about a year and a half working with Brent, he bought a 3D printer. I was like, hey, we can use this. We can build stuff, and we can further the industry and just kind of make tools and stuff that
make our lives easier.
Yeah.
Okay, so you both come from a window cleaning background, and I mean basically you're like a lot of window cleaners are and have been through the years. You're a window cleaner, and you're also an inventor.
Yes.
Okay. Yeah, very good. Well, a lot of the great names, Ederay, Sorbo, a lot of them were the same way, right? They were window cleaner inventors. So good. So you bought a 3D printer, and walk our audience through. I think I know what it is, but walk me even through what's a 3D printer do?
So a 3D printer is basically, you need to think of it as a hot glue gun that just points down, and it feeds rolls of plastic in there. It looks like weed eater cord, and it melts it as it goes through the hot end, and then it just make a layer on layer on layer. And you could do the same thing with a hot glue gun if the glue would dry quick enough. You could just put a new layer and layer. So it's not printing in 3D. It's printing multiple layers of a 2D object that eventually, over and over, that eventually turns into a 3D. So think of it, if you just had a single sheet of paper, that's a 2D object. But if you had a stack of paper, now you have a 3D object. So that's essentially what it's doing.
All right, so it's layering. So when I think of a hot glue gun, though, when that glue dries, it's still kind of like soft and pliable. This is a little different, right?
This is very different, yeah.
There's lots of different types of weed eater cord technically that we can put in there to give it different types of.
Okay. Is it really weed eater cord?
No, it looks just like it. I mean, it's not.
Okay.
I don't have any right next to me, but it's just rolls of plastic, and of course you have PLA, which is what most hobbyist printers use. But then you have ABS. That's when you get into stronger material. PETG, which is what we primarily use now. It's harder to print. Definitely a little bit more experience with 3D printing, but it's the same thing that water bottles are kind of made out of. It's very strong but light. But you can print carbon fiber, wood. There's even 3D printers that print metal. So it's very, very interesting to see, how things are going to develop.
Wow. Yeah, neat. So so this starts off as kind of a hobby. So let's just say I decide I want a thingamajiggy, right? And so I want you to print it on the 3D printer. And what are the steps in order to get the printer to make what I'm wanting? What do you have to go through?
So first of all, we design whatever it is that you want, and that's exported from some type of 3D modeling software. From there, it goes to Slicer, which is another thing of software, and what that does, it converts the 3D object to what's called G-code. And basically that's just a bunch of directions, just a bunch of coordinates for the motors on the 3D printer. And then from there, you put it on the 3D printer. The printer can read that, and it just makes the motors go in a bunch of different places to print those layers over and over. And then at the end, you'll have your 3D printed model.
All right. So who's the brains in this operation?
It's joint brains for sure. That's what this setup is very beneficial, because I'm very like go go go, and Landon is more methodical and thinks things through, unlike me. So it helps to balance it out. I do I would say the majority of innovation, just because I know the industry better, and Landon does all the design work. So he's very, very great. He's going to school for electrical engineering right now, and it's very great because I can just be like, okay, we need a spray applicator. Here's what I need it to do, and here's the shape I think it should look like. And then just from that, he'll have something designed literally within a couple hours at most. So it really works out for us.
So you kind of know what you want, and Landon gets you there.
Yeah, exactly. That's exactly right.
I can resonate with that. My tech team does the same thing for me. So somebody has to lay down where we're going, right? Lay the tracks. So this type of printing, why is it? What advantages does it have over just the traditional? Because it sounds like you still have design. You still have some sort of CAD program that you're putting the design and the piece together that's going to feed into a printer. Well, why is this type of manufacturing better or different than traditional manufacturing?
The first thing is prototyping. That's kind of where 3D printing started. Was people needed to go from idea to an actual physical product. That's probably the number one direction. But where the 3D printing is starting to push is towards small to medium unit runs. So the benefit of a 3D printer is, number one, you don't have to get a mold made. So if you wanted to have an injection mold product, you're going to spend at least $5,000 to get that mold made. And then if you need to make any small change, you got to get a whole new mold made. And then on top of that, you have minimum order runs for that mold that you have to do. And, it's very hard to improve your design, because your ideology is going to be stuck around, well, I already have this mold, so we just got to stick with it. Whereas 3D printing, you can also do very complex geometries that you can't do with injection molding. You can save a whole lot of material, because we have 3D printing uses what's called infill, meaning instead of it being a solid object, you can put basically honeycomb in between the object that gives it better strength, but also saves a whole lot of material. So then it negates cost a lot with your upfront. So if you have somebody that has an idea, in the olden days, you would have to, meet with investors, get a mold made, get your products made, maybe outsource to China or wherever you're getting stuff manufacturing, where now somebody can come to us with an idea, and if it's not, too complicated, we could have a physical product made within that day. So there's a lot of benefits to 3D printing that really trumps, injection molding or, other forms of manufacturing.
Yeah, so I can see that. I mean, I've talked to different inventors in the window cleaning industry, and they'll make something and then they put it out there, and then they get a bunch of responses back, and it'd be great if it was this, or if it had just this little piece, or whatever. And so that person is very hesitant to change it, because he's got a lot of money invested in the mold.
Yeah, exactly.
Yeah, and so then he wants to sell the defunct product for a while so that he can make enough money to make the improvement in the different mold.
Right, you got it.
So what are its limitations? I mean, what couldn't I print on a 3D printer?
Well, it depends. There's multiple types of 3D printing. I think we have to say that first. The ones that we used are called fusion deposition modeling or molding, which is basically the weed eater cord mentality. There's some that use powdered substance on the bottom, and then a laser comes by and cures the powder, layers upon layer, and that you can do metal. A lot of the aviations are switching to the laser type 3D printing, and then you have resin base or stereolithography, I think it's called. So there's a lot of different types, and the materials are kind of limitless. The problem you have with 3D printing, at least on our level, to, a $250,000 printer level is the size. So we're limited by our print bed size, where if we can fit a product in an industry on our print bed, we can make it. But when it comes to the bigger, like a water-fed pole, you're not going to make a water-fed pole on a 3D printer. I guess you could. It would take a very long time. But also the time it takes to print an object. That's the biggest downside of 3D printing, and that's where manufacturing groups have what's called print farms. So right now we're only working on 6 printers. Well, there's manufacturers like Voodoo Manufacturing in New York. They have like 160 printers. So it really can scale by how many printers you have. So
okay,
think of some other ones.
So what? Let's come back to our industry. So you guys are out there, you're slinging the squeegees, and what was the first product that you said, "Hey, let's lay this baby out and let's make this product"? What was the first product?
Well, I say it smiling because it's a hated product. People think it is the dumbest thing in the world, and it was our Bucket Bro or our Bucket Buddy. It started out as Bucket Buddy, but it was Bucket Bro. And the whole reason why we made that is it's cold outside. I have nerve damage in my hands from Afghanistan, and I don't like getting my hands wet in the cold. And so we needed something to wring out your wand. And of course, you can use the back of your squeegee or the side of your bucket, but we're talking about transitioning like storefronts or whatever, where I just don't want to put my glove on there. Even if I have sealskin gloves, I don't want to get anything wet. So we made the Bucket Bro, and we actually got a pretty good response. You either love it or you hate it. And the thing is, people think, when people come out with a new idea, that the innovator is saying everybody needs one. No, everyone doesn't need a Bucket Bro. Like if you live in Florida, you probably don't need one. But if you live in colder climates or things like that, then it would be beneficial, especially post-construction, or you're doing a smoker's house or something like that. I don't want to touch my wand. It's just disgusting. So, there's other benefits to it. But the Bucket Bro was our first. And then the one right after that was the Hog Handle, I think.
Yeah.
Yeah, let me talk about that Bucket Pro for just a minute, though, or Bucket Bro. You guys sent me some samples of those. And I was, in my other business, I was teaching a safety class, and there was, we had a bunch of people in there, and I think you guys sent me like 25 of them. And I gave them away for like good answers in the class. And after I explained what the purpose of it was, everybody in the class wanted one. So, the thing is that it does solve, you look at it from a cold water standpoint, and that's true. So in the winter months, we want to try to keep our gloves as dry as possible. We don't want our hands wet if we're not using gloves. But the other side of that is, even in warm weather, oftentimes what window cleaners complain about is cracked hands. And because they're constantly wet in their hands and they're drying out, and so they'll crack. I remember, years ago when I was cleaning, I could get some deep cracks in my thumbs and hands. And so this actually would eliminate that, as well as not having as much water, drying on your hands. So, once we explained to those guys what the advantages of were, everybody wanted a bucket.
Yeah. And we sent a few out to people just for kicks, and we had some extra ones. We like to give stuff away.
Yeah.
And again, like once we explained what it was, they loved it. So, it's not for everyone, but I think once people had a better understanding, the window cleaning industry can be harsh. So before you explain an idea, you have old school guys, and I get it. The whole water-fed traditional controversy is big. Yeah. But if you introduce something like that, it's like it really steps on people's toes. But it's like, look, we're just making this for us. We're trying to make our lives easier. So it's fun to have it, though, and we still use it.
Yeah, no, it's a cool tool, and it has its purpose, I think. So, the window cleaning industry is it's a finicky breed, but yeah. So, and I just want to remind you guys. You guys said that you love to give stuff away, and I just wanted to remind you that it's very difficult to make any money giving stuff away.
It's true. It's true, and we have people. We want to hear the reason why we like to give stuff away. Again, it's kind of a selfish motivation. We want feedback, not from suppliers primarily. We want primarily people in the field that are beating stuff up, that have a lot of time on glass. that's where we want our feedback coming from, not, suppliers for the most part. So when we give stuff away, yes, we want to, bless people and give them free tools, but we're also looking to get feedback because, we really try to stay humble and stay hungry. So if there's a change that improves it, then let's improve it. You're not gonna hurt our pride, but we're like, no, it's a perfect invention, leave it alone.
Yeah.
So yeah, that's a good point.
I'm just kidding with you. But so then the next tool that you made was it was the hog handle, right?
Yeah.
Yes.
All right. And so why did you look at, I mean, were you guys using hog hair brushes to clean?
Yes, I was doing some high rise. We use it on some new construction or initial cleans. A lot of basically every house in Oklahoma is an initial clean because you're lucky to get a house, even a routine house, once a year. Mm-hmm. So by the time it comes back, it's time to clean again. But I was doing some high rise work with the squeegee squad here on downtown Tulsa, and I was just sitting there using the brush, and eventually your hands get cramped just because you're holding it like this all day, and right. You're trying to reach as high as you can. And it's like, we just need like a more ergonomic handle, and it needs to be high enough where if you have gloves on, your knuckles aren't going to be rubbing on the wood, and just something to where over the day it's just easier on your grip, because by the end of the day, you kind of have locked grip, even if you're just using a squeegee, so you don't need to add a hog's brush on top of that. So yeah.
That was an interesting invention because you start talking hog hair brush, even for high rise guys, that's old school, man. Yeah. Our industry used hog hair brushes before the T-bar. I mean, there used to not be a T-bar out there. Some of these young generation don't know that, but there used to not be a T-bar and mop. And that was the hog hair brush was what a window cleaner used to clean all glass, not just high-rise glass. So pretty cool. Now, I noticed on that product that you guys made, now it would seem that, okay, so the hog hair brush is in the bucket, and I'm reaching down, I'm trying to have this more ergonomic handle, but then you tell us, I think you said in one of your videos or something, that you can't really attach the tool lanyard to the handle. So why is that, or what was the purpose in that?
Well, the material that we use now, first of all, it was a lack of our experience, to be completely honest. We didn't want to risk where, first of all, we're betting on someone else installing the handle, first of all. Mm-hmm. And second of all, people don't tie stuff off properly, let's just be honest. So we didn't want to, as young as our business was, to risk saying, yeah, use it as a tie off, because then you have ANSI standards, you got OSHA standard, we just don't want to be, it's just lower liability. Now, just logically speaking, it would be safer to attach your tie off directly to the core of the brush, not necessarily something that's attached to the brush.
Sure.
But the material we use now, since we primarily use PETG, it's very strong. I mean, we have a prototype we're using right now that's an eighth thick, and you can stand on it and it won't break. So it's very, very strong. But we kind of wanted to just play it safe early on.
Yeah, I would think, because that brush, the one you guys sent me a sample of that as well, and I mean, it would come down to the screws that were in the wood, but the drop test that would have to be performed on it wouldn't really. It's kind of gray, but anyway, I would have to think that basically all it's got to do is support the weight of itself times the drop or whatever, and it's not going to be much weight. So I would be shocked that a tool lanyard wouldn't keep that from going, provided that it was screwed in properly into the wood block.
Yeah, exactly. And once, we have a lot going on. Honestly, we have too much going on as far as inventions and window cleaning and prototyping for people. We will be going back and remaking everything in different material, in stronger structure, mm-hmm. And even there's people that use a hog's hair brush for ground level work stuff, traditional cleans if frames are really bad or whatever the case. So even for ground work, it's great. So we'll be going back and looking at stuff differently.
All right. So we got the bucket, bro. We got the hog handle. What's the next one?
Probably a bunch of Probably thread adapters. Again, it was a problem that we had that we were trying to fix. We needed to run 2 water-fed poles on a job. One, we have an Unger inlight, and the job, I think they're like 55 or 60 feet up, and then you have your apex out and everything. So we were using every bit of the pole that we have. And then his little brother was going to come help us, and we needed him just to do kind of ground level stuff, but we needed another pole. So we're like, we need an adapter that goes from Acme to Euro. So we just Landon designed one up in like 5 minutes, and we printed it and we used it for that job. And then, you know, if it helps us, it could help someone else. So we started doing some thread adapters after that, and some water-fed trad tip adapters. And the wood tip adapter is kind of my go-to. The guy that I worked for growing up, very old school, like water-fed pole doesn't exist. Right. And we didn't use hug towels or anything. And so the cone tip was our go-to. Well, the cone tip, even though it's great, there's always areas you can improve something. So we made it our own kind of trad tip that goes on the end of your pole, and then some that have an Acme tip or a Euro tip on top of there. So a lot of thread adapters. That was our next thing. Okay.
Now you guys made something, this little trolley system or whatever, for a water-fed pole that's basically a spray adapter, right? What's that all about?
Yeah, so we just started the Chariot last month, and our goal there is, again, it was a problem we had. I was washing my stepdad's roof, and he has a metal roof on his barn, and it was a pretty big barn. I think it's about 40 by 60, and I kept falling on it. Like, I was tied off and everything, but luckily, you know, I was tied off because I did fall at least 5 or 6 times, and I was soft washing his roof. Well, I decided if I had my water-fed pole with some type of nozzle, I could just spray it on there. But the pole would need to be supported, but also maneuverable. So we came up with the Chariot to attach to a water-fed pole, ideally just to get people off the roof, preferably me, because I don't want to get up on a ladder or up on a roof and spray, you know, SH up there, and I'm breathing it in or getting my eyes on a ladder. So we made the Chariot, and then we want to get people off the roof, but also get people in the soft wash game that aren't there yet. You know, I have a very new window cleaning business. We have a very new 3D printing business. We don't have enough money for a nice pole and a nice soft wash system right off the get-go, but we can use the pole that we already have. So we designed the Chariot to get people in the game, and there's similar products in the UK. They're a little bit heavier, more expensive, but they attach on the end of a pole. And we wanted something that you could basically daisy chain multiple Chariots onto a pole. So if you had a long stretch of solar panel or a very tall roof or whatever, you know, a steep roof, you could attach it and it be supported in multiple areas of your pole. Okay. And that was kind of our goal there.
Yeah, very nice. So I'm sure you've got more inventions on the horizon. What's your business strategy? I mean, are you just, you know, funning around with different things? It sounds like you've created different solutions for problems in your own business. But I mean, are you taking print orders from other companies? Are you trying to market the products that you are making to distribution? What's your model?
That's actually something we just talked about. So yes, we're doing prototyping for some other innovators in the industry. We do small order runs to medium order runs for, you know, 200 to 400 units for suppliers in the industry. Our goal really, if we see a big gap in the window cleaning market, such as the Chariot in the U.S., there isn't really a Chariot that you can buy or have accessible. So if we see a big gap in the industry, we'll put a product out there. Mm-hmm. But our goal really is just to produce for other people. We really want people to improve the industry, and the easiest way to improve the industry is to have it where an idea can go to a product in the shortest amount of steps as possible and the least amount of money. I mean, that's just the honesty.
Yeah, I can see that play. So I mean, even the Chariot, I mean, yeah, you ultimately don't want to build a bunch of inventory and sell through distribution. You'd rather one of the companies that are already doing that kind of thing pick it up, right?
Yeah. We'd rather make the bullets than, you know, produce the war kind of thing. So we we're not going to go head to head and try to make the next Tucker brush or, whatever. There's already great products out there. If there's an area where, again, a solution that needs to be applied on this product, then we will come out with it. But there's so many, the best innovators aren't manufacturers. I mean, that's the honesty. The best innovators are people in the field. So if we can get them, get their ideas to help other people and help the industry, there's a lot of products that have a very high markup, and that's not the supplier's fault. That's just the natural tendency of manufacturing's fault. So if we can kind of cut that out and get the little guys, so to speak, in the game quicker and improve the industry, that's really the way to go.
Yeah. Do you worry about, though, obviously the printer has some sort of cost, so you've got some money there. And do you worry about other people what stops me from just saying, you know what, I'm not going to pay you guys. I'm just going to buy a printer. I'm going to do this myself.
So, and I don't mean this arrogantly at all. By the time you get a printer, learn what we're still learning, learn how to CAD stuff up and design it, we'll be 3 products ahead. I mean, it doesn't really matter. This is a full-time job in itself. And there's products we plan to give out for free. I mean, just to get people, entice them to get 3D printers and get their ideas out there. The 3D printing industry is very open source. You can go to thingiverse.com. You can get just about anything on there. So we want to make products, we're not trying to hamstring, Tucker or hamstring Ederate or anyone like that. But if there's a product that's severely overpriced, or if we can improve it and we're not really trying to market it, then we will give it away for free. But you got to have a 3D printer. So that's just something we want to do to try to help out. Yeah.
So, all right. And then I would assume that there's everybody probably can't just do the layout in the design, right? So there's a little bit of learning there as well, probably.
Yeah.
That's Landon.
Yeah, your background, Landon, is engineer. So
the thing with it is you can have the idea, but you have to really be able to think, okay, how can I actually build this in a practical standpoint?
Right. So you got an engineer there, and that's in Landon, and that's yeah.
But even with 3D printing, the temperature that the material is printed can affect its strength, its bend, everything. The direction that it's printed, how it's printed. There's so many factors that it's pretty ridiculous, to be honest.
Yeah. Well, you guys are cool guys. It's interesting to see. I'm always intrigued by window cleaners that try to invent stuff. And there's a bunch of them out there now. But everybody tries. So I wish you well. I think you got some cool ideas. And we'll just sit back and watch how you continue to bring products to the market. I really appreciate you two innovators being on with us today, and we're excited to see how things go for you.
Awesome. Well, we appreciate your time, sir. We really do.
Oh, no problem. Thanks for taking some time with us. I'm Mike Draper with AWC TV, signing off. Stay tuned for our next episode of AWC TV by following us on YouTube, Facebook, or our website, awcmag.com.